Hi guys, welcome to today's lesson. Today we will be comparing proportional versus non-proportional relationships. We're going to be doing so in the way of looking at graphs, equations, tables, and word problems. So 4 ways we're going to be comparing proportional to non-proportional relationships. I think this is a very straightforward lesson. If you want, you could even think about it as just trying to spot the difference, really. So before we begin, I do want to review labeling our axes when working with graphs and tables, since that's what our lesson is kind of about. So in case we forgot, we all know that the axis that runs side to side is our x, and our axis that runs up and down is our y, okay? That never changes. This is always the y. This is always the x. One way I like to teach my students is a capital Y has that up and down part right here, just like how the y-axis goes up and down. So for tables, it's kind of the same thing. Just think about it like this. So if you can't remember if the x or y goes here or here, think when you're singing the ABCs, which comes first, x or y? X always comes first, so that's why the x is going to go here, and the y is going to go here, okay? It's always going to be like that. X is to the left, y is to the right, okay? Y is up and down, x is side to side. So the first way we're going to be comparing proportional to non-proportional situations is by looking at their graphs. Now this is helpful if you're, a visual person. But let me just say something before I go on any further. You guys should all be taking notes. So either make tables the way I'm doing that, so that way it's easier for you to tell, but you need to be writing this down because this will help you for your test. This will help you for your quiz, homework, when you have to submit your notes. But take some notes, okay, because this is a fairly easy concept. So let's just get going. Proportional graphs, a couple of characteristics that proportional graphs have that we need to keep in mind is that they will always go through the origin. Now let's think, what is the origin? In a graph, what is the origin? The origin is at 0, 0. So it's when x is 0 and when y is 0, okay? If it doesn't pass through the origin, it can also start at 0. So let me show you some examples of how this may look. Let's see, you got 1 quadrant graph, and I'll give you a 4 quadrant graph. So with the 1 quadrant graph, let's look. It would look something like this, okay? You see it's starting at 0, where x is 0 and where y is 0, right here. Another one would be something like this. It doesn't matter if it's positive or negative, as long as it's passing through the origin. The origin is right there, okay? Origin. See, it's not touching the y, it's not touching the x, it's only touching the origin in 0. So, with this in mind, let's take some notes about non-proportional. If proportional does go through the origin, we can say that non-proportional does not go through the origin. So instead, since it doesn't pass through the origin, we can say that it has a y-intercept. Let me see, y-intercept. So that means it's going to touch the y-axis somewhere, okay? So let's look at it like this. Let me give you another 1 quadrant and another 4 quadrant. So our non-proportional graphs would start somewhere up here. You see that? They're not starting at the origin, they're starting on the y-axis. So they are intercepting the y-axis. Think about it like this. Here's another example. See? This is a negative one, and it's non-proportional. I know that because it's not touching the origin. It is intercepting the y-axis, so it has a y-intercept. Okay, so we just talked about graphs. Now let's talk about what goes hand in hand with graphs. They're equations. So let's compare some proportional to non-proportional equations. Proportional equations do not, like we saw in our graphs, there is no y-intercept, okay? I'm just going to write int for intercept. There is no y-intercept. So what that means for an equation, there is no b. B is our y-intercept, I'll show you, but there's no b, okay? So that means there's going to be no plus or minus at the end. They're all very straightforward. Let me show you an example. So we know our typical equations for linear are y equals mx plus b, right? Well, with proportional, there's no b. So it would just look like this, y equals mx, okay? So y equals our slope, x. Y equals mx. So it could look like y equals 3x, something like that. But there's nothing at the end. There's no 3x plus 2, 3x minus whatever, no. So there's no y-intercept. Now let's look for non-proportional. If we know that the proportional doesn't have a y-intercept, we know that the non-proportional does have a y-intercept. So that means it does have a b in the equation, and that means there is a plus or minus present, okay? So let me show you an example of this. This would look something like, okay, our y equals mx, that's still the same, but it's going to have the plus b. Remember, our b is our y-intercept. These are the same, y-intercept and b. So it has a y equals mx plus b, okay? So another example would be y equals 3x, like from before, plus 4. So we know we have a y-intercept at 4, okay? We could do y equals 7x minus 2. Okay, so we know we have a y-intercept at -2. So this is just y equals mx for proportional. Non-proportional, that's when we have the extra stuff at the end, okay? So we talked about graphs, we've talked about equations. Now let's talk about tables. Tables are like a graph's best friend, right? Okay. So, proportional tables, some notes to take. Whenever we compare tables, we always look at the change of y over the change of x, and we look at what that number gives us. So, y divided by x. When we take y, divide by x with our table, we will always get the same number, okay? We will always get the same number no matter what. In your calculator, take a note of this. In your calculator, when you use stat for a proportional table, b will equal 0. And remember that. Sorry guys, I'm doing this on my phone, and so I get ads on my phone. Okay, back to this. Tables. When we use our calculator for non-proportional tables, we'll have stat, and our b will always equal 0. This is because our b is our y-intercept, right? Our y-intercept. And our our proportional tables, our proportional equations, don't have a y-intercept. That's why b is 0. So let me give you an example of a proportional table. Let's see. 1, 2, 3, 4, 5, 6. And we'll be comparing the change in y over the change in x. And we're going to see if that gives us the same number. If it does, that means it's proportional. So y divided by x, let's see. We'll take these two. 2 divided by 1, that is 2. Okay, let's check. Y divided by x, 4 divided by 2, that is 2. Okay, that works. Let's check this one. Y divided by x, 6 divided by 3. 6 divided by 3 is 2. So when we take the change in y over the change in x, we get the same number every single time. So our x and y is proportionate to each other. Okay? So now let's look at our non-proportional. If our proportional tables have the same number with x and y, our non-proportionals will not have the same number for x over y, okay? Because they are not proportional. Just think about it like that. Not proportional. So let me give you an example of a table. Let me see. And we're going to go ahead and do the exact same thing on the other side. So we're still going to be comparing the y over x, right? Change in y over change in x, and see what that gives us. So let's compare this first one. 3 divided by 1. Y divided by x, we get 3. Okay, good to know. Let's look at this one. Y divided by x, 4 divided by 2. What do we get? We get 2. 3 and 2 are not the same. Okay, let's look at this last one. 12 divided by 3. 12 divided by 3, y divided by x is 4. Do we see these are not the same number? So these are not proportional with each other. That is why this is non-proportional. Okay, so we've talked about graphs, we've talked about tables, we've talked about equations, we've talked about almost everything except for word problems. Now with these, I'm not going to give you a whole word problem and tell you if it's proportional or not. I'm going to tell you the key features of a proportional and non-proportional word problem. So that way when you read it, you'll know what to look for and you'll know, oh, this is proportional. Proportional word problems have keywords. Their keywords go with the m. Now what is m? Remember we have y equals mx for proportional. M is our slope, okay? So the keywords will tell us about our slope. So let me give you some examples. Some examples of keywords for proportional would be something like $10 per hour. Okay, we see this per is a key word, okay? So that means our 10 is our M, okay? Another example would be $20 every 2 hours, right? So every is our keyword, okay? So look for those keywords. Now, here's another note, very important. There is nothing extra they give you for proportional. Very straightforward. Nothing extra to work with, okay? Nothing extra. Now, let's look. Non-proportional word problems. Oh, man. They're also going to have keywords, but these keywords, we need to be smart enough to know that these keywords are about the y-intercept, okay? So it's going to be about our b, okay? So non-proportional word problems, they're going to have keywords that are talking about the b. So some examples, well, let me write this. There is extra info that you have to deal with. There is extra information that you have to deal with. Unlike this one where there's nothing extra, non-proportional has extra information. So some examples I want you to write down include, let's look at this one. We'll keep it the same. $10 per hour plus a $50 bonus, okay? So let's see. I'm looking for my keywords. That says bonus. Well, I see $10 per hour plus a $50 bonus. Per, I know that goes with my M. This plus right here, plus a $50 bonus. That is my B, okay? Plus, see, it has this extra chunk to it right here that this one didn't have. But the plus the $50 bonus, that's talking about my y-intercept. Okay, that is it for today's lesson. We talked about a lot. We talked about graphs, tables, word problems, equations. If you guys have any questions at all or you're confused, first, you should go back and rewatch the video where you're confused. Second, you can message me, text me any questions you have, and I will get back to you. You can also message Ms. Zhangward, and we will be sure to help you out. Otherwise, that's it for today, and I hope all of you have an amazing day, and I'll see you in class.